So what's up guys, welcome to this video. We'll be going over paper 2 of Pure Maths June 2024. Let's go. So first question, we have y is equal to 4x cubed minus 7x squared plus 5x minus 10. We need to find dy over dx. So let's do this one quickly. Dy over dx, fairly simple. We would get a dy over dx that is equal to a 12x squared minus a 14x plus a 5. Okay, very simple. Moving on to the next one. We have to find d2 over d2y over dx squared. So for that one, we're just going to differentiate again. That leaves you with 24x minus 14. Okay. And now for part B, we have to find when d2y or d squared y over dx squared is equal to 0. So for that one, we just need to make the 24x minus 14 equal to 0, so we can work out our x value. And if we do that, we would get a 24x that is equal to 14, and then x is equal to a 14 over 24, which simplifies down to 7 over 12. Okay, so with this question here, we have Jamie. Jamie takes on an interest-free loan of 8,100, and then Jamie makes a payment every month to pay back the loan. The first month is 400, then it's 390, then it's 380, so on and so forth, such that it forms an arithmetic sequence. We can show that Jamie repays £290 in month 12. So how do we do that? Well, what do we know? Well, we know that the first month will be 400, then 390, and then 380, and then so on and so forth until in month 12 we get to 290. So how can we show that? Well, we can work out the formula for this. So if we do that, we are going down in 10. We're minusing 10 each time. So that 4, we get a minus 10n. And how do we get from minus 10 to 400? Well, we just plus 410. Therefore, that is our formula for this. And then if we know that Jamie repays 290 in month 12, we could just put 12 into n, and that should give us 290. So very simple, just do minus 10, then times by the 12, plus 410, and if you work that out, you get a minus 120 plus 410, and that gives us our 290. And for the second part now, we have part B. We can show that we know that after Jamie's nth payment, the loan is completely paid back. So now we need to show that n squared minus 81n plus 1620 is equal to 0. So what we're effectively saying is we're trying to work out basically the sum of adding all these up. So if we do 400 plus 390 plus 380 and so on and so forth, we want to find out, we want to get a quadratic equation which satisfies what they want us to show. So for example, what do we know? Well, we know that once the loan is completely paid back, that means that the sum of n must equal 8,100, okay? Now, what is the formula for this? Well, there are many ways of the formula for an arithmetic sequence, but we know the formula is going to be Sn over n over 2, and then we're going to have in brackets 2a1, well, that's your first term in the sequence, plus n minus 1 d, where d is your common difference. In this case, our common difference is a minus 10, okay? So once we know that, we want it in terms of n, so we're trying to work out, we need expression for n, so we don't need to worry about n. But what else do we know? Well, we know that Sn is 8,100, okay? We know a1 in this case is just a 400. We know our common difference d is a minus 10. So let's put in all our values for this. So we have 8,100 is equal to n over 2, and that is 2 times a1, which is 400, plus n minus 1, and that is times by d, which is a minus 10, okay? And then we just go through this. So we have 8,100 is equal to, actually better still, I'm going to times everything by 2 now. So if we do that, we get a 16,200 is equal to n. We just have n now. And now if we work what's inside the brackets, we will get 2 times 400 is 800. And then we'll get a minus 10 times n. So we get a minus 10n. and a minus 1 times a minus 10 gives us a positive 10. Okay, and now we have a 16,200, and that is equal to n, and let's just simplify this down a bit, so we get an 810 minus a 10n, and then that gives us a 16,200 is equal to an 810n minus a 10n squared. Okay, and now we're at this stage. We can just bring everything to one side of the equation. Let's bring everything to the left side, so we get a 10n squared minus an 810n plus a 16,200, and we know that is equal to 0. And then we can just divide everything by 10. If we divide everything by 10, we get the n squared minus 81n plus the 1,620, and that is equal to 0. Obviously, I should have maybe capitalized the n, but it doesn't really make much of a difference. Okay, so for part C, we just need to work out the value of n. Okay, so fairly simple. This is a quadratic equation. So if we factorize it, feel free to use your calculators if you want. But effectively, if you were to factorize it, you would get n minus 36, n minus 45 equal to 0. So we have that n is equal to 36 and n is equal to 45. So once we reach this, we've got two values here. We've got 36 and 45. The loan has to be paid in the 36th month, because at 36 months, that's when you're initially going to pay back the loan. That's when the sum will just be at 0. Okay. Once we get past 36, we'd get negative values, which doesn't make sense in this. So it will just be 36. Therefore, we can write that n is simply just 36. We can disregard the 45. Okay, so for question 3, we have that the point P, which has coordinates of 3 minus 2, it lies on the curve with this equation y equals f of x. We need to find the coordinates of the point to which P is mapped when the curve with the equation y equals f of x is transformed to the curve with the equations, and these are the equations here. So it's a nice transformation one. With the first one, we have y equals f of x minus 2. So with that one, that's like the f of x minus a. When we have something like that in that transformation, it's just being shifted to the right by 2 units. So if we have 3 to the minus 2, the x coordinate is being shifted to the right, so it's plusing 2, and that's it. So for the first one, it would just be a 5 minus 2. Just remember with this one, when it's an x minus a value, it's always being shifted to the right. If it's x plus, it'll be shifted to the left. Okay. For the second one, we've got f of 2x. So with that one, it's being scale factored. It's been times by a scale factor of a half. So whatever we have with the x coordinate, it's just being multiplied by a half. So in this case, it'll be 3 times a half, which is a 3 over 2, or just a 1.5 to the minus 2. Okay. And for the last one, this one has a lot more going on. So we're 3 of f of minus x plus 5. So for this one, let's do the x value first. So the x value, it's being multiplied by a scale factor of, it'll be the reciprocal, but obviously the reciprocal of minus 1 is just minus 1. So we're just multiplying by minus 1. So if we do that first, therefore the x coordinate is being multiplied by minus 1. We start off with a minus 3, minus 2, okay. And then let's do the 3. So it's being multiplied now by, the y value is being multiplied by a scale factor of 3. So that is a minus 3 minus 6. And then lastly, it's got that plus 5. That plus 5 means that it's being shifted up by 5 units. So the y value is we're gonna add 5 to the y value. So we get a minus 3 minus 1. Okay, and then that will be the answer. Okay, so for this one, we have this sequence here, and we're told that k is a positive constant, and we're told that u3 is equal to minus 1. We need to show that it satisfies 6k squared minus 5k minus 4 is equal to 0. So what can we do here? Well, let's write an expression for u2, okay? So for u2, okay, we know that u2, that would equal a k u1 minus 5, okay? And we know that u1 that is equal to 6, okay? So we can work out what our u2 value is. So that would be a u2 is equal to a k times 6 minus 5. So u2 is 6k minus 5. Now let's do an expression for u3 now. So u3 would just be a k u2 minus 5, okay? Now, what do we know about u3? They tell us in the question, they tell us here that u3 is equal to a minus 1. Therefore, we can write minus 1 here, and we have k times u2, which we worked out, with 6k minus 5, and then that's just a minus 5. And now let's work this out. So we get a minus 1 is equal to a 6k squared minus 5k minus 5. And then if we bring everything to the right side, just bring that minus 1 over, we'd have a 6k squared minus 5k. And then we bring minus 5 plus a 1 is a minus 4, and that is equal to 0. And we have shown that it equals that quadratic equation. Okay, so for part B, we need to work out the value of k, and then we need to find the sum of the first three terms. So for k, it's fairly simple to work out k. It's just a quadratic equation. So for this question, because it's only 3 marks, I would say just do it on your calculator. Like you don't need to work out by hand. It's only for 3 marks, so just do it on your calculator. If you do it in your calculator, you will get k as 4 over 3, and you get k as minus a half, okay? Now, bear in mind that we do have limits in this question, okay? Because we get 2 values, okay? But it tells us that k, tells us right here that k is a positive constant. So therefore, even though we get the 2 values here, we get 4 over 3 minus half, we know to disregard the minus a half. So we know that k is just 4 over 3. And if we know k is 4 over 3, well, we've worked out the value of k, so that's the value of k. Now we need to find this value of the first 3 terms of ur. So ur, that is just u1, u2, and u3, okay? So if I write that here, that is just u1, u2, and u3, and we need to work out the values, okay? So very simple. We know from the question, we know what u1 is. They tell us that u1 is 6, okay? Now u2 is 6k minus 5, okay? And we know that u3 is minus 1 because they tell us that. So really, all we need to do now is work out what our u2 value is. So 6 is here. Then work out what our u2 value is. So if you do a 6 times a 4 over 3 minus a 1, so if I just do that here, if you do a 6 times a 4 over 3, not minus a 1, minus a 5, okay? It's 6k minus 5. If you work this out, you would get 6 times 4 over 3, that is a 24 over 3, so that is an 8 minus 5, and that is a 3, okay? So we know that u2 is just a 3, so therefore we get 6, 3, and we have minus 1. We need to work out the sum, so working out the sum of this is just going to be a 6 plus 3 minus 1, which gives me a grand total of 8. So with this question, we are told that theta is small and in radians, use the small angle approximations to find an appropriate numerical value. Okay, so this is in the formula booklet for you, but I'll just write it here. That is sine. We know that when theta is small and in radians, we can say that sine theta is equal to theta. We can say that cos theta, that is equal to 1 minus theta squared over 2, and then tan theta again is just equal to, or not equal, but it's approximately equal to theta, okay? So with these type of questions, we need to put in these values now where we can. So for example, what do we have? Well, we have theta here. So we'll start with the theta tan 2 theta. Well, we have theta. Now tan 2 theta, if tan theta is approximately theta, then tan 2 theta would just be 2 theta. So we can put 2 theta here, okay? That's the numerator done. And then we have 1 minus, well, if we have cos theta is approximately, 1 minus theta squared over 2. Therefore, cos 3 theta would be 1 minus 3 theta all squared over 2. Okay? And now we need to just kind of solve this. So theta times 2 theta is just 2 theta squared. And then that will give us a 1 minus in brackets, a 1 minus a 9 theta squared over 2. Okay, so for this point here, well, we have a 1 minus a 1, so that's going to cancel out. So we can actually, so we have a 1 minus 1 to 0, and then we have that minus times a minus 9 theta squared over 2, so that gives me just a 9 theta squared over 2. And then from this point on, we have a 2 theta squared that is divided by a 9 theta squared over 2, which is the same as writing 2 theta squared times by a 2 over 9 theta squared. And what does that give me? That gives me, if I write it here, that'll give me a 4 theta squared over a 9 theta squared. And then as you can see, we can just cancel these out, and we're left with 4 over 9. Okay, so we have this figure 1 here, shows a sketch of the curves. We have f of x is e to the power of 4x squared and minus 1, and then g of x is 8 ln x. First question, we need to find f dash x and g dash x. Okay, so let me do that on this page here. So we have a, if I rewrite f of x, we have f of x as e to the 4x squared minus 1, and we have g of x that is just 8 ln x, okay? So if we want to find f of x, well, f of x, we need to differentiate that. So if we differentiate this, what do we get? Maybe change this. This is actually a minus 1 here. Okay, so if we work out f dash x, well, in this case, it's like we can use the chain rule. So effectively, that 4x squared minus 1, we're going to differentiate that, and that will like effectively come out. Okay, so if we differentiate 4x squared minus 1, we just get an 8x. And then we're just left with whatever there. So in this case, we get 8x e to the 4x squared minus 1. And then with g of x, or g dash x, I mean, well, ln x is 1 over x, so 8 ln x is just simply 8 over x, okay? So for part B, we are told that f dash x equals g dash x at x is equal to alpha. We need to show that alpha satisfies this equation, 4x squared plus 2 ln x minus 1. So for this type of question, all we need to do is have f dash x equal g dash x, and we should be able to get it in this quadratic form down below. So let's try that. So if we know that, what do we do? Well, what we can do is if f dash x equals g dash x, that means that 8x e to the 4x squared minus 1, that must equal 8 over x, okay? And now what we can do is we need to solve for x. So let's divide by 8x first. So if we do that, we get e to the 4x squared minus 1. That is equal to 8 over the 8x times x, okay? Because we're dividing by 8x now. We're moving that 8x to the side. If we do that, we get an e to the 4x squared minus 1, and that will just equal 8 over 8x squared. Now that 8x squared, that will cancel down a bit. So if I write over here, we have e to the 4x squared minus 1. That will equal 1 over x squared, okay? So now we're at this stage, okay, what can we do? Well, we can take lns, okay? So if we take lns, we can get rid of that e. So let's take ln. So we will have a ln e to the 4x squared minus 1, okay? And that is equal to a ln of 1 over x squared. So by doing that, the ln times e, that cancels out, so we're left with 4x squared minus 1 on this side. And with this, let's break it up into ln 1 minus ln x squared, okay, just using log rules here. And if we do that, we'll end up with 4x squared minus 1. Now, ln 1 is 0, so we get rid of the 0. We're left with ln x squared. And then another log rule here, we have 4x squared minus 1. And we can bring that 2 down to the front using log rules. So that would equal a minus 2 ln x, okay? And now, pretty simple stuff. Just put everything on the same side of the equation. If we do that, we get a 4x squared plus 2 ln x minus 1 is equal to 0. So we've shown that equation. So for question C, we have this iterative formula. And when we use x1 is equal to 0.6, we can find an approximate value for alpha. So we need to calculate, giving each answer to 4 decimal places, the value of x2 and the value of alpha. So using that formula, if I do it here, we have that x2 that is equal to the square root of 1 minus 2 ln of x1, okay? And that is over 4. So in our case, that would be the square root of 1 minus 2 ln 0.6, okay, because that's what x1 is. And that is over 4. And if you work that out to 4 decimal places, that will be 0.7109. Now that's the easy bit. For this second bit, okay, what we need to do is we want to find a value for alpha, okay? So effectively, we want to find an approximate value for alpha. Now, they say giving each answer to 4 decimal places. So effectively, what we want to do is we want to keep using this iterative formula, keep using it until our value for x is the exact same to 4 decimal places. So for example, if we keep using this formula, right? So if we do x3, okay, we know x3 would be 1 minus 2 ln x2. In our case, x2 is 0.7109 over 4. If we keep doing that, what do we get? Well, if we did that on a calculator, we would get a 0.6485, okay? And then if we keep doing this iterative formula, if we do x4, what do we get if we do x4? If we do the same thing for x4, you get a 0.6830. So as you can see, that is not the same to 4 decimal places. We have to keep going. And then if you keep going, let's do x5. If you do x5 in your calculator, then what do you get? You get a 0.6638. Again, it's not the same. You just have to keep going, okay? Keep going until you get the exact same value, okay? So if you use a calculator, so if I do this on my calculator just to show you, well, I've done the 1 minus the 2 ln 0.6 over 4. And if we do that, obviously we get the 0.7109. So that was our x2, okay? And now, if I just change that 0.6 to the answer function, okay? If we now have it as the answer function, we get the 0.6485, so that was our x3. And we just want to keep doing this until an iteration, it just gives us the same value of alpha to 4 decimal places. So right now, this is 0.6485 equals, so now we're at 6830. And now we keep going, 6638. So just to 4 decimal places, 6745. That is a 6685. Okay, we've got a 0.6718. Okay, again, still nothing. Okay, it keeps changing every time. Okay, so now we're at 6706. Okay, but now we're at 0.6707. Now we're at 0.6706 again. But now we're at 0.6707. And now we're at 0.6706. And now we get another 0.6706 to 4 decimal places. Therefore, alpha is just 0.6706. Okay, that was a bad 6. 6706. Okay, so for this question, we have this figure. It shows a sketch of the straight line L we have line L passing through the points A and B, and relative to a fixed origin O, we have the point A has this position vector here, point B has this position vector. We need to find the vector A, B, okay? So first question, very simple. We have with AB, the vector AB, we know that AB, that's equal to like effectively B minus A. And then we have the position vector of B and A. So just need to work that out. So if we do that, so for B, okay, what's B? Well, B, it has the position vector 5, 6, 8. So as a column form, that'll be 5, 6, 8, okay? And that is minus A, which has 2, minus 3, and 5. And if we work this out, we get a 5 minus 2 is a 3, 6 minus a minus 3 is a 9, and then 8 minus a 5 is a 3. So the vector AB is just 3, 9, 3. So for part B, okay, we're told that given that a point P lies on L such that the distance of vector AP is 2 times the distance of BP, we need to find the possible position vectors of P. Okay, so for this question, let's think of P. Okay, if we have AP here, the distance of AP is 2 times the distance of BP. Therefore, let's say we have a point here. Okay, this is P. Now, if you look at this, AP would be a double the distance of BP in this case, because you can have something like, if we consider this, let's say just like with algebra, like with like, let's say this could be like 2x, for example. This could be like x. This would be x. So effectively, yeah, that is one way we can look at it. Okay, and if we look at it like this, then, well, we have an origin O. We don't know where that origin is. Let's say the origin is, say here. It doesn't matter. It's from a fixed point. Okay. Well, how can we get to P? Because we need to find the possible position vectors of P. So really what we want to find out is OP. Okay, we want to find out OP. So how can we get to OP from here? Well, if this is O, or origin, we can go to OA, and then we travel along, we go to AB, and then just to BP. But what do we know about BP? Well, we know that, this is AB here, okay? If we know that AP is double the distance of BP, well, then this is also going to be an AB. So therefore, to do this one, to get to OP, we need to go to OA first, and then plus AB, and then plus another AB. Okay? So if we write that down here, that means that OP, because we want to find the position vector, which is OP, that is going to be OA plus the AB plus the AB, so that is just 2 lots of the AB, okay? And we know what AB is, because we worked out AB in part A. So, and we know what OA is, because we're told that as well in A. So therefore, all we need to do is, OA, which we know is a 2i minus 3j plus 5. So we have 2 minus 3, 5. And that is plus 2 lots of AB, which worked out in part A. That is 3, 9, 3. And if we work this out, we get a 2 minus 3, 5, plus a 6, 18, and a 6. And if we work this out, we get a 2 plus a 6, which is a 8. A minus 3 plus an 18 is a 15. And a 5 plus a 6 is a 11. So we get 8, 15, 11, okay? That is the first part, though, of P. That is the one of the possible position vectors of P. Now, how do we work out the second one, okay? So for that second point, well, we're dealing with distances, okay? Now, we know that AP has to be double the distance of BP. But we're dealing with distance, okay? So if we're dealing with distance, it can be anywhere. It doesn't have to be, like, AP doesn't have to be huge. Because effectively, if we're dealing with just distance here, then AP can also, if I go make this bigger, AP can also be here, okay? This can also be AP, because all we need to have is that the distance of AP is double the distance of BP. So it can be like this too, because if you think about it, right? If you had this distance, let's call this distance 2x, okay? This distance here, it would still be x. It's still double the distance. So it still satisfies what we want, okay? Now, how would we write this? Well, again, if we have, let's say the origin O is like here, then how can we form an expression for this OP? Well, again, we go from O to A, okay? So O to A, and then we have this AP here. So we get to A to P, AP, but what would that be? Well, if you think about it, if AP is double BP, and I've wrote this 2x plus x so we can kind of visualize it, then that is like it is like a 2-to-1 ratio, right? Therefore, if we want to get an expression for AB in this case, well, then we know that it's like in 3 parts, right? So if we have AP to AB, then that is effectively the same as saying 2 over 3 as a fraction. 2 over 3 AB, okay? So therefore for this one, okay, for this one, we have to, if we want to get the perspective for OP, we have to go OA again, but now we want to plus 2/3 of the AB, okay, 2/3, because that 2/3 AB, that gives us the AP, which is what we want. So now we do this one. So if I write this down here, we have OP, and that is also equal to OA again, but this time it is plus 2/3 of the AB. And if we work this out, we get OA, we know is 2 minus 3, 5, and that is plus 2 over 3 of AB, and we know AB is the 393, okay, so it's 393. And if we work this out, let me do it over here first, we get a 2 minus 3, 5, and then 2 over 3 times 3, that is just a 2. A 2 over 3 times 9, okay, that is a 6, and then that will also give us a 2 here, and that makes our answer as 4, 3, and 7, okay? So therefore, we've worked out our 2 position vectors for OP. It would be 8, 15, 11, and that'll be the 4, 3, and 7. So for this one, we need to prove that 1 over cosec theta minus 1 plus 1 over cosec theta plus 1 is equal to 2 tan theta sec theta. Okay, so to do this one, we need to know our trig identities. So if we have this, what we should do first is let's try and write this over a single fraction, okay? So if we do that, therefore we would get a cosec theta plus 1, I'm just cross multiplying. So cosec theta plus 1 plus a cosec theta minus 1, okay? Then that will be all over cosec theta minus 1 and then cosec theta plus 1. Okay, I've just made it all over one single fraction, okay? Now, next stage. Okay, well, if we have this, if we do the numerator first, well, the 1s will cancel out, so and then we can add the cosec theta together. So we have a 2 cosec theta, and that is equal to, well, this would be a cosec squared theta minus 1, okay? So now we've done all of that. Now, next stage, what do we know about this? Well, using trig identities, we know that a cot squared theta plus 1 is equal to a cosec squared theta. So therefore, if we rearrange this, that tells us that cot squared theta is equal to a cosec squared theta minus 1. So we can just change that bottom value now. So we can change the denominator. So we get a 2 cosec theta is equal to a cot squared theta. Okay? And now we're at this stage. What we can do is let's change that. Let's change all of these around. Okay? So if we change the cosec theta, effectively, we have 2 cosec theta divided by cot squared theta. So we have 2 over sine theta. I've just changed that cosec theta into a 2 over sine theta, and we are dividing by that cot squared theta. Well, what is cot squared theta? That is that's cos theta, and in this case called cot squared theta, it's a cosine squared theta over a sine squared theta, okay? And that is the same as 2 over sine theta times by a sine squared theta over a cosine squared theta. Now, the first thing we can do is, if we look at cross multiplying, we can get rid of the sine. So we can cancel this out with this. So we are left with a 2 sine theta, okay? And that is just over the cosine squared theta. And then lastly, we have this 2 sine theta, and we're going to break up that cosine squared theta into a cos theta times by a 1 minus a cos theta. As you can see, 2 sine theta over cos theta is simply just 2 tan theta. And then 1 over cos theta is just sec theta. Therefore, we have shown it. So for part B now, we have this equation, and we need to solve for x when x is between 0 and 90. 1 over cosec 2x minus 1 plus 1 over cosec 2x plus 1 is equal to cot 2x sec squared x. So we need to solve this now, given our answer in degrees. Okay, so look at what we just worked out here. Okay, we got 2 tan theta squared theta. Now looking at part A, obviously part B is very similar to that. So we can write an expression for this. So if we try and do that now, we go to this page. Now what we can do is, because we already worked out in part A, the only difference is, as you can see, is in this one we have like just a normal theta. This one we have a 2x, okay? Just like 2 theta effectively. Or we just, so really what that means is, if I just write it here, effectively in our answer, it should be like a 2 tan 2x sec 2x. That's the only difference, okay? So if I write that now here, so this is part B, therefore we have a 2 tan 2x sec squared x, and then that has to equal whatever they tell us. They tell us that is cot 2x sec 2x, so that is equal to cot 2x sec squared x, okay? And now we have this trig equation we need to solve. So what can we do with this trig equation? What I would say the best thing to do is just divide, okay? So bring that cot squared x to the other side. Divide both sides by cot 2x sec squared x. If we do that, we get a 2 tan 2x sec 2x, and that is equal to a cot 2x sec 2x, okay? And that would equal a 1, okay? So now that we've done that, now let's simplify this down. Well, easy to start off with. The sec 2x cancels out. So we are left with a 2 tan 2x is equal to a cot 2x, and that is still equal to 1. And then if we have a tan 2x over a cot 2x, well, it's divided by its own inverse. So that is just the same as a 2 tan 2x times by a tan 2x, okay? And that's equal to 1. So we're left with a 2 tan squared 2x is equal to 1. And therefore we get a tan squared 2x is equal to 1 over 2. Okay, and now we're at this stage where we get a tan 2x is equal to plus or minus, because we're square rooting, we go plus or minus 1 over root 2. And if we rationalize that, that will be a plus or minus a root 2 over 2. Okay, so now we're at this stage where we have tan 2x is equal to plus or minus root 2 over 2. Now we need to plot our points, figure out our values. Okay, so to do that, what I will do is we will draw a cast diagram here. So if I have my cast diagram here, now in our cast diagram, all stations towards Croydon. Okay, so we've got this. Now if we work this out, use your calculator. If we make sure you're in degrees as well, So if we do this on our calculator, we will get we do inverse tan of root 2, okay, root 2 over 2. And if you do that in your calculator, you will get a 35.3, okay? 35.3, that's the one decimal place. So we get a 35.3 here. And because we're dealing with just a positive for now, we also get a 35.3 here. Now, because we have plus or minus, okay, that means that we also need to do the inverse tan of a minus root 2 over 2. Now, if you do that, then the only difference is you will then get the same values, but in the negative regions, negative quadrants for tan. For tan, that will be these two right here. So we actually just have the 35.3 in all of our quadrants like this. Okay, now we've done that. Now, in the question, okay, if I go back to the question, they want it here. They want it when x is between 0 and 90. But we've got a 2x. So what we need to do is we need to first consider the temporary limits of the fact that x, or 2x, could be but is between 0 and 180. Because if x is between 0 and 90, we times both by 2. That must mean that for now, our limit, when we're considering 2x, has to be between 0 and 180. So we consider anything which is between 0 and 180, okay? So if we look at this, well, we've got two values between 0 and 180, okay? If we have 2x, we've got the first value is at 35.3. Okay, I'm going to do some extra values. So on my calculator here, I've got 35.264, for example. So let me just do 35.264 just to give some extra values now, and then I can always simplify down later. And then we also have, in that sine quadrant, that will also be less than 180. So in your calculator, you can just do, 180 minus your answer. So that gives me a 144 let's say 736. Okay, just doing as much values as possible. Okay, and now we've done that. Well, those are only values between 0 and 180, and now we can just divide by 2. And if we divide by 2 now, we would get x is equal to a 35.264. If you divide that by 2, you will get a 17.6, and if you divide the 144.736, divide that by 2 to one decimal place, you will get a 72.4. Okay, so we've got 17.6 degrees and 72.4 degrees. And remember, always do it as accurate as possible on your calculator. Don't round down too early. Even though I've given my answers like for 2x to maybe 3 decimal places, keep all your values in your calculator just to be on the safe side. But yeah, answer is 17.6 degrees and 72.4 degrees. Okay, so for question 9, okay, we have this figure, this graph here. It shows the path of a small ball. So we're told that the ball is thrown from point A and it is caught at the point B. Okay, we've got the height. So the height is on our y-axis. Okay, that's in meters. And we've got the horizontal distance that is in x. Okay, and we're told that point A has coordinates 0, 2, point B has coordinates 20, 0.8. The ball reaches a maximum height when x equals to 9. So effectively, that is just this point here. We know this point here has a x coordinate of 9. Okay, like this value here is 9. Okay, and then we have some y value which we don't know yet. Okay, so that is what we're told with the maximum height there. And we're told that it's a quadratic function. A quadratic function linking h with x is used to model the path of the ball. We need to find h in terms of x. So to do this type of question, okay, what do we know? Well, I'll do it on this page here. So we know that if it's a quadratic function, okay, now what is a quadratic function? The basis of the form is y is equal to ax squared plus bx plus c. Now, in our case, we have h and x. So our y is effectively h. So in our case, we have that h is equal to ax squared plus bx plus c. And we need to work out the function, okay? So we need to pretty much get values for a, b, and c, okay? That's what we need to do. Now, in order to do that, well, One thing we do know is we know with this curve here, we know what the y-intercept is because we can see that it crosses at 0, 2. So we actually know our c value straight away. We know our c value, okay, our c value must be 2. Therefore, we have that a is equal to ax squared plus bx plus 2. So we've worked out our c value. Okay, now we need to work out our a and our b values. Okay. Now, first things first, what do they tell us? Well, they tell us that the ball reaches its maximum height when x is equal to 9. So what does that mean? Well, if it reaches its maximum height, if we look at the graph, that maximum height is a stationary point, okay? And if it's a stationary point, that means that dh over dx must be equal to 0, right? And we know that that's at the point when x is equal to 9 because they tell us that in the question. So if we differentiate this, we can get dh over dx. So if we do that, we get dh over dx, and that would equal a 2ax plus b, and that must equal 0. So that would be a 0 is equal to a 2ax plus b. Okay, and we know that x is 9 at this stationary point, so we can plug in that. So we get that 0 is equal to a 2a times 9 plus b. And if I rewrite this, that is a 0 is equal to a 18a plus b. Okay, that's a 9. And therefore, we can get an expression. So how does this help us? Well, we know that a minus b must equal an 18a, okay? Or effectively, we also, by that, we know that b is equal to a minus 18a. So if we know b is equal to minus 18a, well, we can just plug in the value for b or a into b, okay? And that can give us everything just in terms of a now. So if we do that, what do we get? We get h is equal to an ax squared. And then b, in this case, is minus 18. So we get a minus 18ax plus a 2. Okay, so now all we need to do is try and figure out what that a value is. So what can we do? Well, if you look, we have 2 points on the graph. We have 0, 2, and 20 and 0.8. Now, we can plug in any of those values, and that should give us a value for a. But the problem is, we can't plug in 0 and 2 into x and y, because if you plug that in, you will just get you get a times 0 plus 18a times 0, and you just be left with 2. It doesn't really help us, because we want values for a. So really, you need to plug in the 20 and the 0.8, okay? We need to plug in the 20 and the 0.8, okay? So if we plug that in to our x and y values, we'll just be left with a, and then we can find out our unknown a. So if we do that, we get h, which is 0.8. That is equal to not a 20, that is equal to a times a 20 squared minus an 18a times by 20 plus 2. And now we've done that, now we can work out a value, okay? So we get a 0.8, that is equal to a 400 a. Okay, be careful not to put a squared, because it may be tempting, but remember, it's just a times the 20 squared. It's not all of that times squared, it's just the 20 squared, so it's 400a. Then we have 18a times 20. 18a times 20, that is a minus 360a plus the 2. So then let's bring that 2 to the other side. So we get a 0.8 minus a 2, which is a minus 1.2. And then a 400a minus a 360a is a 40a. And then if you do minus 1.2 divided by 40, okay, you get a, and that would equal a minus 0.03, okay? And that does make sense, because if you look at it, right, if a is ax squared, then if we look at the graph, it's in that n shape. So therefore, our a value should be negative, at which it is. So that's a good sign. Okay, so we get a as 0.03. So we worked out a. Now let's just finish off working out b. So we know b is minus 18a. So b is just a minus 18 times by a minus 0.03. And if you work that out, you get a positive 0.54. Okay, so now we worked out A, B, we worked out C. Therefore, H, if we work out H must be A equal to ax squared, which is minus 0.03x squared. And then that's plus the bx squared. We know b is 0.54, so plus 0.54x, and then just plus the 2. So we need to give one limitation of the model. So these questions, there's loads of limitations. I mean, the easiest one I would say is just doesn't take air resistance into account. So you say like part B does not take air resistance into account. Okay, something like that. Okay, now part C is we got Chandra. She is, I assume it's a she, I don't know, is standing directly under the path of the ball at a point 16 meters horizontally. Chandra, she can catch the ball if the ball is less than 2.5 meters above the ground. Use the model to determine if Chandra can catch the ball. So effectively, if Chandra is standing horizontally at 16 meters, then what does that tell us? That tells us that, for this question, tells us that our x value in this case is going to be 16, okay? X is equal to 16. And then we're also told that if the ball is less than 2.5 meters above the ground, she can catch it. Okay, if the ball is less. So effectively, all we do is work out the vertical height of the ball when it's 16 meters horizontally. And to do that, we just need to put that into the equation. So therefore, it'll be h is equal to a minus 0.03 times by the 16 squared plus 0.54, and that is times by 16, and then plus the 2. If you work that out on your calculator, you will get h as a 2.96. So if h is 2.96, well, in the question, it says that she can catch the ball if it's less than 2.5 above the ground. Well, we have 2.96. That is not less than 2.5. It's not less than 2.5. Hence, Chandra cannot catch the ball. Okay. So for question 10, we have this curve here, and we have the parametric equations of x equal to t plus 3 squared, and we have the 1 minus t cubed, okay, where t is between minus 2 and 1. We've got the point P with coordinates 4, 2, it lies on C. Using parametric differentiation, we show that the tangent to C at P has equation 3x plus 4y is equal to 20. Okay, so let's start that over here. So what do we know? So we know that x is equal to t plus 3 squared. We know that y is equal to a 1 minus t cubed. So first things first, let's expand the brackets out for this x value. So we get a t squared plus 6t plus 9. Okay, and y would stay the same. So let's, first things first, let's do a dx over dt. Okay, we're doing it by, we have to do it by parametric differentiation. So that gives us a 2t plus a 6. And for the y value, if we do dy over dt, that is just simply going to be a minus 3t squared. Okay. Now, if I do this on the next page, what do we know about dy over dx? Well, we know that in this case, if we want to look at dy over dx, that is the same as dy over dt times by a dt over dx. Okay. So in our case, we know that that would be a dy over dt, that was a minus 3t squared times by, well, if this over here, if this value over here is dx over dt, therefore a dt over dx, that would equal a 1 over a 2t plus 6, okay? Just do the reciprocal. Therefore, this, for dt over dx, it would be a 1 over a 2t plus 6, which equals a minus 3t squared over a 2t plus 6. So we worked out dy over dx. Now, why are we working out dy over dx? Because we need to work out the equation to the tangent. Okay. And what do we know? Well, we have our x value as 4, as we know from the question that this curve lies on 4, 2. So we have the x value as 4, we have the y value as 2, and we just need to work out this m value here. So now that we've worked out dy over dx, we can now, if we figure out our t value, we can just plug that t value into the dy over dx, and that will give us our value for dy over dx. So again, what do we know? Well, we know that x is equal to t squared plus 6t plus 9. We know y is equal to a 1 minus a t cubed, okay? So how can we work out that value? It's very simple. If we know 4, 2 lies on c, well, we can just plug in 2 here, and that must equal 1 minus t cubed, okay? And if we do that, we get 1 is equal to a minus t cubed. Therefore, a minus 1 is equal to a t cubed. Therefore, t is equal to a minus 1. So we've worked out our t value. Now, you can also plug in your x value as well, and you can still work out t that way. For example, in this case, it will be a 4 is equal to t squared plus 6t plus 9. Bring the 4 to the other side, you get a t squared plus 6t plus a 5 is equal to 0. And if you work this out, you would get that would be what would that be? A 5 and a 1. So you get t is equal to minus 1 and minus 5. Because you get two values, and you may think, oh my god, I get two values, why don't I get one? But remember, there are limits in this question here. So because it has to be between minus 2 and 1, we would then just disregard this value here. And again, we're still left with minus 1. So you can do it either way. But yeah, t is minus 1. So if we know t is minus 1, that means that we can put that value into the dy over dx. So we have that dy over dx is equal to a minus 3t squared over that 2t plus 6. And if we plug in our value now for t, that would be a minus 3 times by a minus 1 squared. And that is over a 2 times minus 1 plus 6, which if you work that out, you would get a minus 3 on the numerator, and you would get a 2 times minus 1 minus 2 plus 6, you'd get a 4. So therefore, we get dy over dx is minus 3 over 4, so that means our m value is minus 3 over 4. And now that we know that, we have everything we need. We have our x value as 4, we have our y value as 2, and we have our m value as a minus 3 over 4. And now we need to plug that into the equation of a straight line formula, so that is just y take away y1 is equal to mx take away x1. So that is a y minus a 2 is equal to a minus 3 over 4 x minus a 4. Let's times everything by a 4 now. So we'll get a 4y minus an 8 is equal to a minus 3x. Minus 3 times a minus 4 is a positive 12. And then let's bring everything to the right side of the equation. Oh wait, no, what form do they want it in? They want it in the form of, okay, so they want 3x plus 4y equals 20. Therefore, we bring the 8 to the other side, we bring the 3x to the other side. So we are left with a 3x plus 4y is equal to 20, like they've asked for. So for part B, we're told that the curve C is used to model the profile of a slide at a water park. Units are in meters with y being the height of the slide above water level. Find, according to the model, the greatest height of the slide above water level, okay? So for this question, we're just dealing with the y value. Okay, we're just dealing with that y value here, and we know that the y value is 1 minus t cubed. And we want to find the largest height we can get. Well, if we remember that we have this thing here, that t is between minus 2 and 1. Okay, t is between minus 2 and 1. So if t is between minus 2 and 1, then with this type of equation, which one of those values, like what can we get as the biggest value, okay? So if we think about it, okay, we have that we have minus 2 is less than or equal to t, which is less than or equal to 1. Well, if we put 1 into the equation, actually, that just gives us a 0, okay? Because if we do like 1 minus a 1, that would just give us 0 meters. So again, it won't be 1. But if we use the minus 2, well, the minus 2, that'll be a 1 minus a minus 2. Just be careful of your signs. It's a 1 minus a minus 2, okay? And that'll give us a 1 minus a minus 8, which is a 1 plus 8, which therefore gives me a 9 meters, okay? So we're just using the limits which they give us for t. We plug that into the y coordinate, and yeah, we plug in the minus 2 because, again, we want the biggest value, we want the greatest height. Minus 2 gives us the greatest height, so therefore we use the minus 2, and therefore we get 9 meters. Okay, so this question, again, we have this sketch, part of curve C with equation y equals 8x squared e to the minus 3x. And we've got this region R, okay, and as you can see, that is bounded by when x is equal to 1, and also the x-axis where x would be 0. We need to find the exact area of R, and we need to give it in the form of a plus be to the minus 3. So this question is a nice question, you know, just a simple integration, area under the curve. However, as you can see, we've got two values for x here, which means that we're going to need to use integration by parts. And another thing, if you see, we've got an x squared, and you may not realize this now, but we're effectively going to have to integrate, we're going to have to do integration by parts a few times to get our answer. So it's a nice 5 marker, but it is a long 5 marker, okay, a very long 5 marker. So let's start this off. So for this question, if we're using integration by parts, therefore the formula is here. I believe this is given to you in your formula booklet as well. But yeah, we have u dv over dx equal to uv minus the integral of v du over dx with respect to x. So all we need to do now is, if we write this out, that is the integral of 1, 0, okay, and that is 8x squared e to the minus 3x. We need to just integrate this. That's all we need to do, is just integrate this. So if we use integration by parts, well, let's choose one of them to be our u value and the other to be our dv over dx value. So for our u value, let's choose the 8x squared, okay? Now we have to use the 8x squared. The reason for that is because we cannot use the e, because if you integrate e or you differentiate e, whatever, it's going to be the exact same. We have to use the 8x squared, because if we keep differentiating that, then it will eventually become a constant, okay? So therefore we get u as 8x squared, okay? Now for our dv over dx value, okay, so if we have dv over dx here, that would then just be our e to the minus 3x, okay? Now, what's du over dx? Du over dx, that would just be a 16x. And our v value, if we integrate this, that would be a minus 1 over 3 e to the minus 3x. So we worked out our values. Now let's just put that in. Okay, so we have I, that is equal to uv. So uv is the 8x squared times by the 1 over 3 e to the minus 3x. So what would that be? That would be a minus 8 over 3 8 over 3 x squared. Let's do the x squared first. So let's say minus 8 over 3 x squared e to the minus 3x, okay? That's uv, and that's minus the integral of v, which we know is going to be that minus 1 over 3 e to the minus 3x times by that 16x. So that would be a minus 16 over 3 x e to the minus 3x, okay? And now we need to integrate that. So now we've got an integral with an integral. Therefore, if I just clean this up a tiny bit, we have 8 over 3 x squared e to the minus 3x. And now I'm going to take out that minus 16 over 3. So we get a plus 16 over 3, and then the integral of x e to the minus 3x. And we need to integrate that with respect to x. So now we have this xe. Well, if we do it over here again, our u value is going to be x, and our dv over dx value, that would be the e to the minus 3x. So now if we work this out, we get a du over dx that is equal to a 1. And we get a v that is again equal to a minus 1 over 3 e to the minus 3x. Therefore, what do we get? Well, we still have that minus 8 over 3x squared e to the minus 3x. That stays the same. Now we get the plus 16 over 3 and then all of this in brackets of uv. So uv is minus 1 over a 3x e to the minus 3x, okay, and that's minus the interval of v du over dx. So v du, that's just a 1 over 3 minus 1 over 3 e to the minus 3x, and that is just respect to x. Okay, so now luckily we now know that, okay, we just need to integrate one more time and then we are done. So if I write that here, if I just clean this up again, we get a minus 8 over 3 x squared e to the minus 3x, okay, plus the 16 over 3. That's equal to the minus 1 over 3x e to the minus 3x. And now we're going to take out that factor of the minus 1 over 3, so we get a plus 1 over 3 integral of e to the minus 3x dx, okay? And now let's do this one more time. So we get an I is equal to a minus 8 over 3 x squared e to the minus 3x plus the 16 over 3, okay? And that is minus 1 over 3 x e to the minus 3x. And that is plus 1 over 3 times, that would give us, if we integrate this one final time, we get a minus 1 over 3 e to the minus 3x, okay? And then all of this is all being, has the limit of 1, 0. So now let's simplify this down and then we can put in our limits. So if we simplify this down, we get I is equal to a minus 8 over 3 x squared e to the minus 3x plus a 16 over 3. Okay, and then we have a minus 1 over 3 x e to the minus 3x minus a 1 over 9 e to the minus 3x. And then again, that's all being raised to 1, 0. And now let's finish this off. So I is equal to a minus 8 over 3 x squared e to the minus 3x. Now we have that 16 over 3 times by minus 1 over 3. So that would be a minus 16 over 9 x e to the minus 3x. And then we have a 16 over 3 times by a 1 over 9. So that will give me a minus 16 over 27 e to the minus 3x. Okay, and all of that has a limit of 1, 0. So now we can just put in our limit of 1, 0 to get our answer. So if we do that, so if we start with 1, then we get a minus 8 over 3, 1 squared is just 1, so that stays the same. Then e to the power of minus 3 times 1 is just e to the minus 3. Then we get a minus 16 over 9 times by x, so times by 1. And then e to the minus 3 times 1, so we get another e to the minus 3 here. And then again, we get the minus 16 over 27, e to the minus 3 times 1, so that's just an e to the minus 3. Okay, so that is 1. And then for 0, well, we have an x squared, so that whole thing would be 0 there. Then we have the x, so that's another times by 0, so that cancels out. And we are just left with a minus 16 over 27 e to the 0, which is just 1, so we don't even have that. That's just a minus 16 over 27. And if we were to simplify this down, well, as you can see, for that first brackets, right, everything is e to the minus 3, so we can put them all together. So if we start putting everything together, okay, if we do minus 8 over 3, minus 16 over 9, minus 16 over 27, if you add them all up, what do you get? You get a minus 136 over 27 e to the minus 3, and then with that minus, a minus 16 over 27, so that gives me a 16 over 27. And therefore, if we write it in the form they want, that would just be 16 over 27. minus 136 over 27 e to the minus 3, where both a and b are rational numbers. So for 12a, we just need to express 1 over v, 25 minus v in partial fractions. So to do that, that means that we have a over v plus b over 25 minus v, and that must equal the 1 over v and then 25 minus v. So if we just do some cross multiply now, we get that a times 25 minus v plus bv, that must equal 1. So if we make v 25, therefore that cancels out the a, we're left with 25b is equal to 1. Therefore b is equal to 1 over 25. And then for secondly, if we make, let's make v 0, that cancels out the b. Therefore, we're left with 25a is equal to 1. So a is also equal to 1 over 25. Therefore, to express it in partial fractions, if I do it here, it would be a 1 over a 25v. And then that will be plus a 1 over a 25 times 25 minus v. Okay, so part B, we've got this volume V, which is in microliters of a plant cell. T hours after the plant is watered is modeled by this differential equation here. We're told that the plant cell has an initial volume of 20 microliters. We need to find, according to the model, the time taken in meters for the volume of the plant to reach 24 microliters. Effectively, all we need to do is work out a general equation to this differential equation. And once we work that out fully, we just need to make V equal to 24, and then that will give us our t value. So first thing first, we need to work out the general equation. So if I do that on this page here, what do we know? Well, we are told that dv over dt, that is equal to a 1 over 10 v 25 minus v. So how can we work out the general equation? Well, again, with these, we want to get all our v's on one side and then all of our dt's, or all of our extra values on the other side, right? So in this case, we know that from part A, okay? Part A, we have this form here. So really, when it comes to these type of questions, when they tell you to express something in partial fractions, they want you to use that in the next bit. So really, what we want to do is we want to get some type of expression where 1 over v, 25 minus v, is on that same side as the dv. So to do that, we can clearly see that if we just move the v times the 25 minus v, if we divide by that, we bring it to the other side, it's going to be 1 over, which is what we want. So if we do that, we bring that v 25 minus v all to the left, and then we bring that dt to the right. So what are we left with? We are left with 1 over that v 25 minus v, and that is equal, well no, that is dv, and that is equal to a 1 over 10 dt, okay? And with differential equations, what we need to do is we need to integrate, okay? So we need to integrate both of these sides. So first thing first, let's break up that partial fractions. Now, as we worked out in part A, we know that that would be a 1 over 25v, okay? And that is plus a 1 over 25 minus v, okay? And that's all with respect to dv, respect to v, okay? And then with this side, let's integrate the right side now. So if we do that, if we integrate that with respect to t, then it's just going to be a 1 over 10 t. And let's add our constant now. We'll add our constant c, okay? And now let's integrate. So before we integrate, let's take out a factor of 1 over 25. So if we do that, we get a 1 over 25. That would be a 1 over v plus a 1 over 25 minus v, okay, with respect to v, and that's equal to 1 over 10 t plus c. So we integrate this left side now, we get a 1 over 25, okay? Now 1 over v, if we integrate that, that is simply just going to be ln v. And integrating the 1 over 25 minus v, remember, we need to, if we differentiate that denominator, we get a minus 1, okay? So it's a minus ln 25 minus v, okay? That is key, just remember it's going to be a minus. And then that is equal to 1 over 10 t plus c. And now what we can do is let's times both sides by 25, so we get rid of the fraction. So we get a ln v minus a ln 25 minus v, and that is equal to, if we do that, 25 over 10 gives us a 2.5t. And with that c, well, that just gives us another constant, okay? Because we get a 25 times c. So effectively, let's 25c equal b. It just gives us a new constant, so we can just write that as b for now. Okay, so now that we've done that, let's join our lns together. So we have a ln v over 25 minus v, okay, using the ln rules or log rules. That is equal to 2.5t plus b. And now let's e everything. So if we e everything, we get an e to the power of ln v over 25 minus v. That is equal to e 2.5t plus b. Now remember, again with this, we can write another constant because we can let e b equal a, okay? Because with that e is the same as saying e 2.5t times e to the b. So we can let e to the power b equal another constant, which is a in this case. So if we do that, if we now simplify this down, we are left with a v over a 25 minus v is equal to a e 2.5t, okay? And now we're at this stage. Okay, we are told in the question that it has an initial volume of 20 microliters. So what does that mean? That means that initially, when t is equal to 0, v must be equal to 20. And we can use that to work out our constant a. So if we do that, we get a 20 over a 25 minus 20. That is equal to an a times e. So e would be to the power of 0, which is 1. So this would just give us a. So therefore, that's a 20 over a 5, which is a. So a is just 4. Okay, a is 4. If you know a is 4, then we've worked out a general equation to this. The general equation would be just v over a 25 minus v is equal to a 4e 2.5t. And now in the question, they say that they want us to work it out when it reaches 24 microliters. So now we can just plug in v for 24, and then we can work out what t is, okay? Okay, so if we plug in 24 now for v, what do we get? We get a 24 minus a 25 minus 24. That is equal to a 4e 2.5t. So that's a 24 over 1. That's just a 24 is equal to 4e 2.5t. So that would be a 6 is equal to an e 2.5t. And at this stage, we take lns on both sides to eliminate the e. So we get a ln 6 is equal to a ln e of the 2.5t, and then that cancels out. So we're left with ln 6 is equal to a 2.5t. Therefore, t is just going to be a ln 6 over a 2.5. And if you did that in your calculator, you would get, let's put some decimal places in, you would get a 0.7167. But what is that 0.7167? That represents hours, okay? Because in the question, it says t is hours. But in the question, we want it in minutes, okay? It wants it in minutes. So therefore, if we've got 0.7167, just times it by 60. And if you times it by 60, you will get, I believe, 3 single figures. You will get 43 minutes, okay? So for part C, we need to show that v is equal to a over e to the minus kt plus b, where a, b, and k are constants to be found. So for this one, okay, well, we have the expression, general equation here. So effectively, we need to get v all by itself. So if we have this, well, if I rewrite that here, this is part C now. Okay, so we know that we have that this v over t to the 25 minus v is equal to the 4e to the power of 2.5t. Okay, so if I just bring that down here, Therefore, if we want to work out what v is, well, an easy way is we just need to, first things first, times by 25 minus v to both sides. So we're left with v is equal to 25 times the 4 will give us 100 e to the 2.5t, and then also times by the minus v, so we get a minus 4v e to the 2.5t. Now let's bring all our v's on one side, so we get v plus 4v e to the 2.5t, that is equal to 100 e 2.5t. And then we can factor out the v, so we get v, and then brackets 1 plus the 4e 2.5t, and that is equal to 100 e 2.5t. And then if we bring all that to the side, we get a 100 e 2.5t, and that is over a 1 plus a 4e 2.5t. In the question, okay, we have that all the e to t's are negative. It's all on the denominator as well. So one last thing we can do is we just bring that e to the 2.5t down to the bottom. And to do that, it would be 100 over, if we bring it down to the bottom, bring it to the denominator, it will just be e to the minus 2.5t, okay? And that is times by 1 plus the 4e 2.5t. And if we just work all this out, well, we get a 100. And then we have a e to the minus 2.5t times 1 is just e to the minus 2.5t. And then those e's will just cancel out with each other, because we'd get minus 2.5t plus 2.5t is just a 0. So we're just left with that 4. And then that would be our answer, 100 over e to the minus 2.5t plus 4. So for part D, okay, we're told that there's an upper limit L microliters on the volume of the plant cell. We need to find the value of L, giving a reason for our answer. So for this type of question, okay, we have the expression for V. Now we need to pretty much just find the limits, or in this case, more or less find the range, okay? So what do we know? Well, we know that in a normal standard just exponential graph, we know that e to the power of x is always going to be greater than 0. Now, by that definition, in our case, we have e to the minus 2.5t, that will also be greater than 0. And then we have that e to the minus 2.5t plus 4, if we just plus 4 now, we know that in our case, the denominator, it will always be greater than 4. Now, if it's always greater than 4, what does that mean? Well, if you think about it, we'd have 100 over 4, which is 25, okay? That is pretty much the biggest value you can have, because if the denominator has to be greater than 4, well then, if you think about it, we're going to get 100 over 5 or 100 over 10 or 100 over 20 and so on and so forth. T is just going to keep going up, right? So the largest value we can have for V is just 100 over 4. And 100 over 4 is just 25. So yeah, L is just 25. Since the denominator has to be greater than 4, therefore the biggest value we can get is 25. As the denominator keeps rising, as t goes to infinite, then our values of v are just going to get smaller and smaller. Okay, so L is 25. Okay, so question 13, we have the world human population, P, which is in billions, is modeled by this equation. P is equal to A times B to the power of T, where A and B are constants and T is the number of years after 2004. So using the estimated population figures for the years from 2004 to 2007, a graph is plotted against log base 10p against T. And we're told that the points lie approximately on a straight line with a gradient of 0.0054, intercept 0.81 on the log base 10p axes. And then we need to estimate to 3 decimal places the value of A and the value of B. Okay, so if I do that here, then we start off knowing that P is equal to AB to the power of T. But then they tell us that it's against log base 10, okay? The y-axis is log base 10. So they've actually, in order to solve this, they've turned everything into log base 10. Therefore, this is log base 10p is equal to a log base 10 a b to the power of t, okay? That's what they've done to work this out. They've made everything in 2 logs. So what we can do is let's split this up, okay? So if we split this up, we get log base 10p, that is equal to a log base 10a plus a log base 10b to the power of t, okay? And then we can go another step further. That'll be a log base 10p is equal to a log base 10a, and then we can bring that t to the front, so it'll be a t log b, okay? Okay, so one thing they tell us in this question is they tell us that the points lie approximately on a straight line. Now, what does that mean? Well, we know the formula for a straight line, right? That is just y is equal to mx plus c. And we can rewrite our equation in that form. So effectively, log base 10p, okay? That is our y value. And then we have log of base 10, this would be a base 10, b, okay? All of that is effectively our m value in this case, because t would be our x value. So, and then our constant, that would be the log base 10a. So as you can see, we have got this in that form here. So we can work out our values. We can work out our a value straight away. So what are we told? Well, we are told that, if we go to the question, we're told that our intercept is 0.81. So if we go back to this, well, if we know that our constant now has to be that log base 10a, that has to be our constant, okay, because we've written it in the form of the y equals mx plus c. Therefore, log base 10a must equal the 0.81, okay? So if I write that here, we know that log base 10a must equal the 0.81. And now we need to solve for a. So if you do that, that would be a would be equal to a 10 times by the 0.81. Now, if you're unsure what to do, then this says like, what do I do with what? I always like to do an example in my head. I don't know why, but for some reason, in my head, I always think of this example. Log base 32 is equal to 5, okay? And then in my head, I'm like, well, 2 to the power 5 is equal to 32. And then I just look at that and I compare where my numbers are, and that helps me kind of figure out where my numbers need to go. Just in case you're always like, what do I do? How do I rearrange this? Just think of it like this. So we know that so if I do that, that tells me that it has to be 10 to the power of 0.81. And if you do 0.81 on your calculator, you will get to 4 decimal places. You will get a 6.4567. Okay. So now our A is a 6.4567. Okay. So now if we go back to this, okay, we know that if we're doing it in the form of mx plus c or mt plus c, we know that this value here, this is our m value, okay? And this is our m value, that's our gradient, okay? Well, if we look at the question, it tells us that our gradient is 0.0054. So we know that all of that log base 10b must equal, okay, all of the log base 10b must equal a 0.0054. And the same one, that means that b is equal to a 10 to the power of a 0.0054. And if you work that out, what do you get? So to 4 decimal places, you get a 1.013, okay? So we've worked out our b value and we've worked out our a value. And I believe that was the question. Yep, to 3 decimal places, work out the value of a and b. So we've done part A. Now, part B, we need to interpret what the value of the constant A and what the value of the constant B means. So, if we rewrite this, well, from the question, we were told that P is equal to AB to the power of T. So what does that mean? That means that P is equal to A, which is 6.4567, plus B, which is 1.013 to the power of T. Now this also, I wrote this as, this is supposed to be a times. Now, what do we know about this? Don't we need the times there? So what do we know about this? Well, this is like an exponential equation, okay? And we know that in this form, therefore, the 6.4567, that is the initial value, okay? That's the initial value. So we know that with A, so with I, okay, we know that that is just the initial value of the population So we can write something like initial value of population um, in 2004. Okay, something like that. We can just write that. So in 2004 or in the beginning of 2004, something like that. So for part B, we need to work out the value of B. Well, B, as you can see, that's just a 1.013. And really what that is showing, it's just like showing like the yearly increase, okay? So pretty much, it's like the scale factor of the yearly increase. So you can write the scale factor of the yearly increase. It's just the multiplying factor, okay? So you can write the scale factor of the yearly increase in the population, something like that, okay? For part C, we need to use the model to estimate the world human population in 2030. So what we need to do is work out what a t value would be in 2030. Well, if t is the number of years after 2004, so we know that when t is 1, that's 1 year after 2004, and then t is 2, that's 2 years after 2004, so 2006, and then so on and so forth. So t would have to be 26, okay? So if t is 26, well, then we just put that into our formula. We know our formula is p is equal to 6.4567 times 1.013 to t. So in this case, p would be a 6.4567 times a 1.013 to the power of 26. Put all that into your calculator, and you would get a 8.921 billion. Okay. So for part D, we need to comment on the reliability to the answer to part C. So we need to pretty much figure out, is this model a reliable way to estimate the human population in 2030? Now, I know what you're thinking, okay? You're probably thinking that, well, we don't know what's going to happen in the future. There could be some apocalyptic event happen, or, there could be like a COVID 2.0 coming. We don't know. There's so many things which we don't know could happen in that space. So how can it be reliable? Remember, if you put that, this is an A-level maths exam, okay? They will not put something in the exam where there'll be some apocalyptic event or something like that. That just won't be in the exam, okay? So for this question, you need to relate it really to the model. So if you look at the model, well, the model is between 2004 and 2007, okay? And we are trying to say that, is it going to be reliable in 2030? Well, not really, because it's just so far off. Like, the data will be outdated, okay? So you need to really relate it to the model we've been given and the years we've been given. If this is between 2004 and 2007, it's going to be outdated, okay? So it's not really a reliable method. So you can put something like the model is not reliable because it may be outdated, okay? It may be outdated, okay? And something like that, and you are done. It's only 1 mark. So for question 14, okay, we have this circle which has this equation. We need to find the coordinates of the center of C1 and the radius of C1. So a pretty nice question towards the end of the paper. So we need to rewrite this in the circle equation formula. So let's group up all my x values first. So we have x squared minus 6x plus y squared plus 14y plus 33, and that is equal to 0. Then let's rewrite this. So let's complete the square. So we get an x minus 3 squared, and then we get a minus 9 coming out of that. We get a y plus 7 squared, and we get a minus 49 coming out of that, and then we plus the 33 equal to 0. So we get an x minus 3 squared plus the y plus 7 squared. Now we have a minus 9 minus 49 plus 33. So that's a minus 58 plus 33, which is a minus 25. And that is equal to 0. Therefore, our equation for this would be a something like this: x minus 3 squared plus y plus 7 squared is equal to 25. So what does that tell me? That tells me that this circle has a center of 3 minus 7, and it has a radius of 5. Okay, so for this question, we have these two circles. Now, we know the center of both. Okay, we know that the center is 3 minus 7 for that circle C1, and it's minus 6 minus 8 for that circle C2. And what they're telling us is we need to find the value of k. So k is the radius, okay? So k is the radius of that circle C2. We need to find when it will have two solutions. So right now, I've just got it here. I've got the two circles, and both of them, they intersect at 2 points. Okay, they would intersect at that point there and this point here. Okay, so that intersects at 2 points. We need to find the values for the radius of k. So k is the radius of that C2. We need to find the values of that. So if I just show you what I mean. So if we let's say k is here, for example. Okay, let's say that we have this length. Okay, and this is radius k. Okay, this is radius k. Well, as you can see, at this point here, k just intersects at 1 point, okay? Intersects at 1 point. Okay, but really what we want is we want to know the values when k intersects at 2 points. So, if I was to expand this circle, or if the radius was to get bigger in this circle, which would mean the circle would expand, the circle would get bigger. If we expand, well, as you can see, we're at one solution here, 1 point. But as the radius gets bigger of that circle, it keeps getting bigger. It's still hitting 2 points, still hitting 2 points on C1, still hitting 2 points. Well, we're still hitting, and then boom, right there. It's going to hit 1 point again, okay? 1 point again. So if it's 1 point again, that'll be like right here. So effectively, that's what we need to figure out, okay? We need to figure out that range of k. So if we think about that, if we go back down, so k is small, 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 still hitting 2, and then it hits 1 point here. If we can figure out that value for k at that point, well, then that will be one of our limits, okay? K will have to be greater than that value, okay? Because that's when it hits at 1 point. So how do we work out that value? Well, we have 3, 7, okay? If we look at it here, let's use the green one, okay. Well, we can work out the distance, the length of the center of C1 and the center of C2, because we have both center points, okay? So using Pythagoras' theorem, okay, if we have 2 points, I'll just do it over here. We have the point here, which is 3 minus 7, with the point here, which is minus 6 minus 8, okay? That is effectively, we can just use Pythagoras' theorem. So by doing that, well, we have minus 7 and minus 8. So we know that is a distance of just 1. Okay, so we know 1's there. And then with the minus 3 and 6, that's a difference of 9. Okay, so we can look at the length using Pythagoras' theorem. We know that that is just going to be a 9 squared plus 1 squared. So therefore we get 82. So what does that 82 mean? Well, that means that the whole length of the centers between the center, all of that must be 82, okay? So all of this must be length root 82, okay? Now, if we know that's all length root 82, we know that here, this has a radius or length of 5, right? Because the radius is 5, so we know that this must have a length of 5. We know that the other circle C2, that must have a radius of k, okay? But we know that total length has to equal root of 82. Therefore, we know that right here, k plus 5 has to equal root 82. And using that, we actually can get an expression for k. So we know that k is equal to root of 82 minus 5, okay? Effectively, that's like, I believe it's like maybe 4.1, maybe? I guess 4.1. So you can think of k as like 4.1, but we want the exact value, okay? So the exact value would be root 82 minus 5. So you know at this point here, the radius of k is root of 82 minus 5, okay? And if I just if I keep that there, get rid of this, then remember what I did earlier, okay? Remember what I did earlier when we expand it. So if we know that is root 82 minus 5, then we need to also keep going, and it's still hitting at 2 points, 2 points, 2 points, 2 points, and right there, now it's hitting at 1 point, okay? It's just going to hit at 1 point over here. So now what we need to do is we need to figure out k, but now we need to figure out k for a much bigger value, okay? Now, instead of k just being this small value, okay, k just goes all the way through. K effectively now is all of this, because it's the radius of k. So now k is all of this. Like if I do another color here, we want to work out the radius of k, okay? So so k is all of that. That's all of k now. We want to work out the radius of k. So if we look at it, well, we know from the two centers, we know the distance is root 82. And we know that with the small circle, it has a radius of 5. So there's radius 5 here. So from the minus 6 minus 8 to the 3 minus 7, that has a length of root 82. And then we know from that 3 minus 7 to the point where they intersect, that just has 5. So now k would be root 82 plus 5. So we know that for this, k has to be less than root of 82 plus 5. So that k has to be less than root 82 plus 5, but k also has to be, oh god, my k is so bad, has to be greater than root of 82 minus 5. And now we need to write that in some set notation form. So what we can do is we can write that as like k such that root of 82 minus 5, which is less than k, which is less than root of 82 plus 5. Okay, we can write it in this form here. So what we're showing is that k has to be a value in between root of 82 minus 5, which is, I guess, like 4.1, and then k has to be less than, it has to be less than that root of 82 plus 5, which is like 9.1. So it has to be in between those two values here. Okay, last question. We have the curve C has equation x plus y cubed equals 3x squared minus 3y minus 2. We need to find an expression for dy over dx in terms of x and y. So we need to use implicit differentiation now to work this out. So this gets very meaty. Okay, so first things first. Let's expand the brackets out. Let's expand the x plus y out. So this is part A. If we expand the brackets out, we get, I'll do it twice. So the first bit, if we do x plus y squared first, we get an x squared plus 2xy plus a y squared, okay? And then we have another x plus y, and that would equal the 3x squared minus 3y minus 2. Just make this bigger. And now let's just expand all this out and simplify it down, and then we can differentiate. So if we do this, we get x squared. I'll do the x squared, so we get x cubed. And then we get the x squared times y is an x squared y. Then we get a plus a 2x squared y. And then we get plus a 2xy squared. Then we get a x, y squared. You have to be very careful with this, not to make any mistakes. It is very easy to make mistakes, so just try and be very slow and just take your time with these. And you get 3x squared minus 3y minus 2. Okay, so now we're at this stage here. Okay, so let's simplify down now, and then let's bring everything to one side, because why not? So we have x to the power of 3. This would be a 3x squared y. Then we have another 3xy squared plus the y cubed. And then, we just bring that. So it's a minus 3x squared plus 3y plus 2, and that is equal to a 0. So now let's integrate this. So for the x to the power of 3, well, that is just a 3x squared. Now with the 3x squared y, okay, I'm going to do the product rule in my head. So with the 3x squared y, that would give us we'll get a 3x squared, okay, we'll get a 3x squared dy over dx. And then if we differentiate the 3x squared, that gives me a 6x. So we get a 6x and then times by that y. So it's just 6xy. Okay, so that's that 3x squared y done. And with the 3xy squared, what do we get? Well, we'd get a 3x times by a 2y dy over dx. So we get a 6xy dy over dx, okay? And then we would differentiate that 3, okay? So we get just a 3y squared. Okay, a 3y squared. Now, if you're unsure, you can always use the product rule with this to work it out. And then with that y cubed, that would just be a 3y squared dy over dx. And then the 3x squared, that would be a minus 6x. And then we'll just be left with one last thing, and that would be the 3y, which would be a 3 dy over dx. And this is all equal to 0. Okay. So now what we want to do is we want to bring all of our dx terms together and then bring all of our non-dx terms together. So let's do that. So if we do that, that will be a dy over dx. Okay, we're going to put it all in a bracket. So we have the 3x squared. We have the 6xy. We have the plus the 3y squared. And we have plus 3. Okay, that's all of our dy over dx. And all of our non-dy over dx terms will just bring it to the right side of the equation. Okay, so I'm bringing it to the right side of the equation. So that would be a minus a 3x squared. And then our next value is at 6xy. So a minus 6xy. Then with that 3y squared. So a minus a 3y squared. And then with that minus 6x. So it's a positive 6x. Okay. And therefore, if we now just need to divide through, so if we divide, that would be dy over dx is equal to a minus 3x squared minus 6xy minus 3y squared plus 6x, and that is all over 3x squared plus 6xy plus 3y squared plus 3. So for part B, we have that the point P, 1, 0 that lies on C, and we show the normal to C at P has equation of y is equal to minus 2x plus 2. So to work this out, well, if we want to work out the normal to C at P, then we need to know our x values, our y value, our m value, which is our gradient value, and then I'll work out our n value, which is our normal gradient, because we want the normal to C at P. So luckily they've given us 1 and 0 for x and y, so it makes working out our gradient easy. So we just plug in 1 and 0 to our x and y values. So if we do that, what do we get? Well, we get a minus 3 times 1 squared, so that is a minus 3. Now, that 6x has a 0, so that cancels. No, it has a y, so because of that y, that just cancels out because the y is 0. Same with the y squared, it's a 0, so it just cancels out. And we have a 6 times a 1, so that is just a 6. Okay, so that's our numerator. And with the bottom, we have a 3 times a 1 squared, so that's a 3. We have a y, so that cancels out because it's 0. Y squared cancels out because it's 0. And then we just have a 3 here. And if we work that out, we get a 3 plus a 6, which is a half. Okay, so we know that our m value is minus a half. And then our n value, our normal gradient, that's just a negative reciprocal, so that's just a minus 2. And that's all the information we need to know. Now we can use the formula. Y take away y1 is equal to n x take away x1. And if we work that out, well, we get a y minus 0 is just a y is equal to n, which we know is a minus 2, x minus 1. And if you work this out, you get y is a minus 2x plus 2. Okay, and last question. We need to prove that the normal to C at P does not meet C again. So we need to use algebra for this proof and make our reasoning clear. So how do we prove that this does not meet, that the normal does not meet C again? Well, let's consider that it would meet C again, okay? Let's just work it out, because effectively that's just simultaneous equations, right? So if we have the normal to C at P, we can make that equal to the curve, and then if it only meets C if it doesn't meet C again, that must mean that it only meets C at one point. Okay, so if we work this out via simultaneous equations, we should only get one set of values, okay, for x and y. If we get multiple values, therefore it's going to meet at various points. So let's work this out using simultaneous equations. So let's just, first things first, let's just consider that, the normal, I'm just going to write this, don't need to write this, but I'm going to consider that the normal does, let's consider the normal does meet C again, okay? So if we consider that, well, what do we have? Okay, we know that the curve was x plus y cubed, and that is equal to the 3x squared minus the 3y minus 2. And then we also have the normal to C at P, that is y is equal to minus 2x plus 2. So if we make these equal to each other, okay, we should only get 1 point, okay? But let's consider that it does meet again. Let's consider that it meets again, okay? So let's just solve it. Let's just solve it, okay? So let's just solve it. Let's consider that it meets again. Why not? So if we do that, then for what can we do? Well, we have an expression now for y, so we can just plug that in. So if we plug that in, we get x plus the minus 2x plus 2, all cubed, and that is equal to a 3x squared minus 3 of minus 2x plus 2 minus 2. So now we're solving it via simultaneous equations, and we need to solve our x and y values, okay? So if we do that, therefore, this would be a minus x plus 2 cubed, and this would equal a 3x squared plus a 6x minus a 6 minus a 2, okay? Now, if we expand the brackets out, let's do minus x plus 2 squared first. So if we do that, we get an x squared minus a 4x plus a 4. And then we're going to times by another minus x plus 2. And then if we simplify this down, we just get a 3x squared plus 6x minus 8. And if we expand this out again, what do we get? We get a minus x cubed plus a 2x squared. We get a positive 4x squared minus an 8x. And then we get a minus 4x plus 8, okay? And that's equal to the 3x squared plus 6x minus 8. Now, if we bring everything to the left side, we get a minus x cubed. We bring that the 3 over to the side, so we get a 2x squared plus 4x squared minus the 3x squared. So that would give me a positive 3x squared, okay? We have a minus 8x minus a 4x, that's a minus 12x. And then we're going to bring that plus 6x over to the sides, that's a minus 12 minus 6. So minus 18x, and then we have the 8, and bring that minus 8 over, that will be a positive 16 is equal to 0. So now we have this cubic, okay, and I'm going to just times everything by minus 1 to make it look better. So we get an x cubed minus 3x squared plus 18x minus 16, that is equal to 0. Okay, so in the question, because we know that the point P 1, 0, it lies on C, we what do we know? Well, if we know that x is equal to 1, that means that x minus 1 is a factor. It's a factor of our cubic equation, okay? So therefore, now we can do algebraic division. So if we do algebraic division, okay, let me do that here. That is x cubed minus 3x squared plus 18x minus 16. We know x minus 1 is a factor. Now we can use algebraic division to get our quadratic equation. So if we do that, therefore we do x to the power of 3 divided by x, that gives us an x squared. And x squared times by x is x to the 3. X squared times by minus 1 is a minus x squared. And then we're going to minus all of this. Okay. And if we do that, we get a 0, x squared, and then we get a minus 3x minus a minus x squared, which gives me a minus 2x squared. Bring that 18 down. Then we do the same thing. A minus 2x squared divided by x is a minus 2x. And then minus 2x times by x, minus 2x squared. A minus 2x times a minus 1 is a positive 2x. And we're going to minus everything again. And then that gives me a 0x squared. 18x minus 2x is a positive 16x. And then we bring down that 16. And then we have 16x divided by x is 16. And from there, we do 16 times by x is just a 16x. 16 times 1 is a minus 16. Take them both away from each other, and you are left with 0. Okay, so now work that out. What does that mean? That means that x to the 3, okay, x to the 3 minus 3x squared plus 18, 18x, minus 16, that equals x minus 1. If we factorize it, equals x minus 1, and then what was our answer? We had x squared minus 2x plus 16, so that equals x squared minus 2x plus 16. Okay, so now we've factorized this. So now, we know x minus 1, we know x equals 1 is a factor. We need to work out this x squared minus 2x plus 16. So we need to work this out. X squared minus 2x plus 16 is equal to 0. But so if we think about this, well, if we said, well, we can't just factorize this normally, right? Then how can we prove that this has no solutions? Because effectively, x is equal to 1, that is supposedly the only solution we have. So what can we do? Well, we can use the discriminant, okay? We can use the discriminant, b squared minus 4ac. So we know that in this case, a would be 1, b would be a minus 2, and then a c would be a 16. So if we do the discriminant, what do we get? We get a minus 2. Let's write that b squared minus 4ac. So if we do that, that's a minus 2 squared minus 4 times 1 times a 16. So that gives me a positive 4 minus a 64, which is a minus 60. Now, minus 60 is less than 0. And when we have the discriminant, b squared minus 4ac, and when it's less than 0, that must mean we have no solutions. Therefore, this x squared minus 2x plus 16 has no real solutions. Therefore, x is equal to 1 is only solution. Okay. Therefore, what does that mean? That means that it only hits. That means that it only intersects at 1 point. Okay, like 1, 0. Okay, and then we've shown that because, well, when we try, because we can't solve x squared minus 2x plus 16, it has no solutions. Therefore, x equal to 1 is the only solution we have. Therefore, it must only intersect at that point. So yeah, that would explain it, and that would be the paper done. So I hope you enjoyed this, and yeah, we'll be going through some more past papers, so stay tuned for that. I hope you have a great day, and I will see you on the next.